Dr. Jason Liu. I'm a research fellow at the University of Leeds.
And the machine behind you is a road construction machine?
Yep, so we're calling it the road repair drone. It's a UAS that we're planning on demonstrating. That it's a drone that can land on road surfaces and seal surface cracks and defects on road surfaces before they grow into larger potholes, which is a very common problem in UK roads.
Will it be actually sent out to a specific area or will it be able to identify and fill?
So the grand vision is have a full autonomous fleet of drones like this that can operate autonomously around the whole city. So if we're imagining sort of a human body where we have white blood cells that can just travel around and fix any problems that it identifies, we want a city that can fix itself with either drones or ground vehicles.
How are you dealing with artificial intelligence in the actual project?
That is something we are working with. Our project also works with Birmingham, Southampton, UCL. So it's a very problem with Leeds. We're mainly working with the platforms themselves.
When it comes to the Civil Aviation Authority, weight limit is a huge issue. How are you dealing with that and being able to do repairs with the 3D system?
So with the CAA, the main legislation is either sub 7 kilos or 7 to 20 kilos. Our drone with full payload for our road fixing capabilities will be 15 kilos, so well within the CAA limits on those. To get autonomously flying, we will need more special permissions from the CAA to develop a strong safety case to prove that they are safe to operate in cities.
How long would the battery life be, do you reckon?
With our payload of about 1.5 kilos of asphalt, we can operate for at least 20 minutes. But with autonomous fleet, is while one lands, replenishes asphalt and batteries, another drone's already taken off to continue the job of repairing roads.
Thank you and good luck with your project.
Thank you.
My name is and I work at the Center for Advanced Robotics at Queen Mary as a researcher. So at Queen Mary we develop soft and inflatable structures, and one of them is this prosthetic hand, which has a soft actuators inside that we developed having in mind prosthetics for children. So the benefit of this hand is that it is safe, inherently safe, so this means the child cannot hurt himself, and the hand can be easily scaled up as child grows and as child develops. So it can lift up to 1 Newton, but we believe it is sufficient for child to gain again the possibility to grasp objects and to interact with the environment. So here we are using pneumatic actuations, and pneumatic actuation is safe, right? So this means we don't have any bulky motors the child is interacting with. So we are having safe inflatable structures that also can be immersed in water. University of Surrey. Travel basically.
Interesting. Why do you need to raise interest? Surely it's interesting.
My name is Pete Blacker. I'm a PhD researcher working at the Surrey Space Centre. My work's in collaboration with Airbus Defence and Space on the next generation of Mars rovers to follow on from their existing mission they're working on, the ExoMars rover, launching in 3 years. Right, here we've got the fusion sensor itself. So this is a combination of a 2D scanning LiDAR and the two stereo cameras here, and that combines with the pan tilt unit to be able to move the 2D LiDAR, giving you the ability to produce 3D LiDAR point clouds, and that can get combined, as you can see on the background here. So the 3D information from the LiDAR is then meshed, and then the camera information, so the colour information from the camera, projected over the top of that 3D information, and this allows us to quickly produce very high quality, long range 3D scans of the environment. And this is very important for the Mars rovers, because at the end of the day they need to be able to perceive their environment, to be able to find safe routes to traverse the terrain. And currently the range that they can perceive the terrain at the moment is limited to about 10 to 15 metres at the most, which is limited by the limitations of stereo vision. And this technology is hoping to really extend the capabilities of these machines a lot, so they'll be able to see about 100 metres from a single point and allow them to produce better routes, so safer routes, longer routes, which effectively is going to make them move faster than they can today. So Mars rovers are amazing machines, but they're very, very slow. Curiosity's been on Mars for many years now and hasn't even gone 25 miles. So a lot of people don't realise how slow these things go. So the next generation of missions, such as the European Space Agency's sample fetch and return mission, are going to have to move faster because they need to get to a particular point to collect samples, bring them back again. So this work is focused on trying to improve the perception with the aim of increasing the speed that they can move across the surface of Mars. So here you can see just a single raw 2D point cloud. If you started to do a scan, this will move up and down across the scene to produce a 3D point cloud of the terrain around, so in this case just the inside of the exhibition. And when these point clouds are collected, a triangular mesh is created over the 3D data and the camera image projected over the top, and this allows a very, very high quality, very accurate and detailed 3D model of the environment to be produced. And in this case, you can't see that off the ground, but this is then used by the later stages on the rover to produce an accurate terrain map, which can be used then to find safe routes, work out which areas the rover can and can't drive over, and get it towards its goal on Mars.
Is that always? You never know where you're going.
Maybe Spain we're going out. My name's Stuart Golding, I'm Managing Director for a company called Electromechanical Systems. And we're here today working with our business partner, Dr. Fritz Faulhaber from Germany.
And you produce?
We produce small electric motors, so small DC and brushless DC drive technology used in a wide variety of application areas, particularly prosthetics and robotics.
How many different types of drives do you do in total?
Well, we have a vast range of drive technology, starting from just 2mm diameter, used in implantable technology, right through to 44mm diameter, so the application field is really quite broad.
When it comes to medicine and robotic hands and things like that, how important do you think servos are to the industry?
Really vital to the industry. They're the engine of many of these technologies, so they're the drive source. So really you're looking for a high power to weight and density. So you're looking to get the most power from the smallest size motor. Really efficient, because quite often you're relying on battery capacity, so you're looking for very, very low current draw and high efficiency and power to weight density technology. Well, piezo technology is not so much developed at the moment from a sort of productionized capacity, so the motor is more dynamic than a piezoelectric motor, so they have some interesting characteristics, but they're not really as usable in the market as a DC or a brushless DC motor.
Thank you and good luck.
Thank you very much. Good to talk to you.
So that's gone there. This literally was a case of, did you see in the Netherlands and Ireland?
Hello, yes, my name's Chris Edwards. I'm the Operations Director at CNC Robotics.
And what's going on here?
Okay, well what we're demonstrating today is actually the trimming of the inner and outer shell of a polo helmet. And that's actually a carbon fibre shell on the left there. And this is a Kevlar and carbon composite shell. And what it does is we trim the outer surface on both sides and put together the final assembly with a honeycomb in the middle that acts as a shock absorber. So the finished item is there with the outer skin covered with a material finish, and we also drill the holes here for ventilation. So that's what we're demonstrating.
And you're based in Aintree, aren't you?
We're based in Aintree, yes, in Liverpool.
And you had an interesting setup. You weren't originally Robotics, were you?
Well, we actually originally started out in the stage and set design business, and our MD, Jason Barker, thought that he'd invest in machinery, found that machine tools were quite expensive, and decided to look at robotics instead. And now the business is more robotics, there's no more stage and scene, so it's progressed completely into robotic integration. That's what we're doing.
Thank you and good luck.
Okay, thank you very much. Pleasure talking to you today.
My name's Nick Palmer. I work at the University of Liverpool for the Business Gateway. Our role is to connect organisations and businesses with our academic departments and career service to find out what their needs are and to provide services such as consultancy, continuing professional development and contract research. I also work with my colleague Paul.
Hi, I'm Paul Cullivan from the University's Careers and Employability Service, and we look to engage with companies who are in a position to recruit our graduates, final year students for graduate employment who can offer internships, placements year in industry opportunities.
And how do the people get in touch with yourselves?
Yeah, for the career service, careers@live.ac.uk.
So that's careers.ac.uk.
Yes, my name is Alison Mitchell and I am the Executive Director at Sensor City.
And what is Sensor City?
Sensor City is an innovation hub specialising in support for businesses interested in sensors and Internet of Things. It's a joint venture between the University of Liverpool and Liverpool John Moores University, and it gives companies access not just to academics, to students, but also to fantastic facilities within the building.
And can any business or student get involved?
Yes, any business can get involved at all, and even if they just want to find out a bit more about the Internet of Things, come to one of our events, they're all on our website, or come in and take a hot desk or take an office with us.
And how do they find your website?
It is on under Sensor City. If you search under Sensor City, it will be there.
And now your building is very interesting. What is it?
It's a very striking building on Russell Street, just behind Lime Street. It is a collaborative hub. It has a circuit board design on the front in bright yellow, and it's known as the circuit board building by taxi drivers.
Ration type stuff, where a robot can actually tell that there's a human there because of its e-signature. Yeah. Stick between obstacles and